In this lesson, you will learn why, in some cases, you specialize relationships to improve query performance and how to use an APOC procedure to dynamically merge a relationship into the graph. Neo4j as a graph database is implemented to traverse relationships quickly. In some cases, it is more performant to query the graph based upon relationship types rather than properties in the nodes. Let's look at a new use case. What movies did an actor act in for a particular year? We can execute this query with the current graph. It returns the movie Apollo 13. What if Tom Hanks acted in 50 movies in the year 1995? The query would need to retrieve all movies that Tom Hanks acted in and then check the value of the release property. What if Tom Hanks acted in a total of 1,000 movies? All of these movie nodes would need to be evaluated. And here is another new use case. What actors or directors worked in a particular year? Again, we can execute this query with the current graph. It returns Tom Hanks and Martin Scorsese. This query is even worse for performance because in order to return results, it must retrieve all movie nodes. You can imagine if the graph contained millions of movies, it would be a very expensive query. Relationships are fast to traverse and they do not take up a lot of space in the graph. In the previous two queries, the data model would benefit from having specialized relationships between the nodes. So, for example, in addition to the acted in and directed relationships, we add relationships that have year information. At first, it seems like a lot of relationships for a large-scaled movie graph, but if the latest two new queries are important use cases, it is worth it. This is what our instance model will now look like. In most cases where we specialize relationships, we keep the original generic relationships as existing queries will still need to use them. The code to refactor the graph to add these specialized relationships uses the APOC library. This is the code to refactor the acted-in relationships in the graph that you will execute in the next challenge. It has an apoc.merge.relationship procedure that allows you to dynamically merge relationships in the graph. It uses the 4 leftmost characters of the released property for a movie node to create the name of the relationship. As a result of the refactoring, the previous two queries can be rewritten and will definitely perform better for a large graph. Here is the rewrite of the first query. For this query, the specific relationship is traversed, but fewer movie nodes are retrieved. And here is how we rewrite the second query. For this query, because the year is in the relationship type, we do not have to retrieve any movie nodes. In the next challenge, you will execute the code to specialize the acted-in and directed relationships. Then, in the final challenge, you will specialize the rated relationships. This completes our look at why, in some cases, you specialize relationships to improve query performance and how to use an APOC procedure to dynamically merge a relationship into the graph.